Hello learners, this class is for BSc second sem physics. We'll discuss what is the work done in isothermal process. We'll derive the work done expression for isothermal process. So let us consider 1 gram of mole of some ideal gas that is expanded isothermally. Okay, gas expanded isothermally. Okay, when we say gas is expanded isothermally, we mean work is done by the gas. Okay, work is done by the gas, because we have seen that in the PV diagram in the last video, right? Work is done by the gas here. Okay, so we can also see that in the PV diagram or the indicator diagram. Okay, so if this is a initial position or P1, okay, let this be A and B. At this V1, okay, let this be at V2. So let us take some intermediate state, okay, that is CD, okay, where the volume is changing little bit, that is dV. Let us suppose at this point the pressure is a little bit like constant. Okay, let P1 V1 be the so I'll write here P1 and let this be P2. Okay, let P1 V1 be the pressure and volume at initial state, that is at A, and P2 V2 be the pressure and volume at the final state B. Okay, so during isothermal expansion means isothermal. Do you remember what is isothermal means? Isothermal means the process in which temperature is constant. Okay, temperature is constant, and as we are saying gas is expanded, so the work done has to be work is done by the gas. That means work is positive, work done is positive. Okay, let P and V be the pressure and volume at any intermediate state. Now as I have said, okay, now we assume that pressure remains constant. At this point the pressure remains constant for a small increase from C to D. So the work done by the gas during this expansion, the work done is equal to PdV. We have seen this, how we got this work done magnitude also in the last video. Okay, dW is equal to PdV. Let this be equation number 1. We need the net work done by the gas during the total entire process, during the total expansion, that is from volume V1 to V2. We need net work done by the gas during this expansion from V1 to V2. Volume changes from V1 to V2, no? So the net work done by the gas during this expansion is given by W is equal to integration of dW from V1 to V2. So we know dW is equal to PdV. Okay, PdV. Let this be equation number 2. Okay, now for an isothermal process, we have PV is equal to RT, or from this we can write P is equal to RT by V. Okay, here Boyle's law holds good. So PV is equal to RT, that is P is equal to RT by V. I have written P is equal to RT by V and mentioned it as equation number 3. So putting this third equation into in second equation. Okay, so we know W is equal to PdV. We got PdV, no? So there I am writing in the place of P, I am writing RT by V and dV. Okay, because what is the second equation? Second equation is PdV. So in the place of P, I am writing third equation. Right? So W is equal to RT is a constant. So I am taking it outside. Integration of dV between V1 and V2. 1 by V. 1 by V into dV. So what we get? W is equal to RT. Well, we integrate 1 by V dV, we get log natural logarithm of V. Okay, and putting the upper limits and lower limit, V1 and V2. So we can also write this as W is equal to RT log base E V2 minus log base E V1. Okay, we can write it like this. So W is equal to RT log. So log A minus log B can be written as, you know this, log A minus log B can also be written as log A by B. So log V2 by V1 of base E. Okay, let this be question number 4. Or for logarithm with base 10, we can write 2.3026 RT log base 10 V2 by V1. Okay, this is equation number 5. So, as I said, W is equal to the entire dW can be written as like PdV for the entire process, PdV. Integrating it for the entire work done. Now for an isothermal process, PV is equal to RT, so P can be written as RT by V, and substituting this equation in W is equal to PdV. So instead of P, we are writing RT by V here. Okay, RT by V dV. So that becomes RT is constant, so we are taking it out. V1 to V2 integration of 1 by V dV. So when we integrate this, we get logarithm of base E V and putting the limits V1 V2. So W is equal to RT log V2 minus log V1, applying the upper and lower limits. Okay, now W is equal to, this also can be written as, just now I said, log A minus log B is nothing but log A by B. So we can write log V2 minus log V1 as log V2 by V1. Okay, we can write it like this. So in terms of natural logarithm with base E, if you want in the base 10 logarithms, then we can write W is equal to 2.3026 RT log 10 log base 10 V2 by V1. Now if you want in terms of pressure terms, then what we can do? As we know, for an isothermal process, P1 is equal to P2 V2. From this we can write V2 by V1 is equal to P1 by P2. So in place of V2 by V1 in equation 5, in place of V2 by V1, we can write P1 by P2. W is equal to RT log P1 by P2. Or W is equal to 2.3026 RT log base 10 P1 by P2. This is the required work done equation in an isothermal process. Okay, work done in isothermal process. I hope you understood. Thank you.